morning, students. Today, the third day of this chapter, velocity and accelerations. In previous class, you have studied about the speed, velocity, rest and motion, reference point, and so on. Yes. Today, let's discuss about the acceleration and retardation. What is that acceleration? What do you mean by acceleration? And what is that retardation? Okay, so let's talk about it. First of all, let's take some of the concept about the acceleration. What is this acceleration? Acceleration means the rate of change of velocity of a moving body, that is called what? Accelerations. It means, let's look the chart over here. This is the velocity, stop A and a stop B. Okay, look at carefully. When a body or when a car starts from rest A, at the time this is in rest position. When it starts, the velocity is increasing. It means the velocity is increasing. After the sound, the uniform velocity continuously, and when it going to stop at the B, its velocity is what? Decreasing. It means there is a clearly you have seen in this graph. Yes or no? The rate of change of velocity of a moving body, that is called what? Acceleration. So now, once again, let's consider, let's the car start from the rest A. Let's the car starts from the rest stop A. When it starts moving with the velocity is increasing. When this from that point A, stop A, when the car starts, the velocity is what? The velocity will be increasing. And after a certain time, it gains a constant velocity. After some time, it gets a constant velocity. Yes or no? And as the stop B approaches, its velocity gradually decreases and finally becomes zero at the stop B. It means after the some constant velocity, the body or the car will be decreasing, and when it reaches to the its velocity will be decreasing and it stops at point B. Means this concept gives us what? The rate of the change of velocity of a moving body, that is called what? Acceleration. Okay, so acceleration means what? The change in velocity by the time taken. The sum of the time is taken or not? You have seen here. The velocity is increasing or decreasing? The increasing velocity? Yes or no? And the sum of time is taken. It means the change in velocity is called by the time taken, that is called what? Acceleration. Yes or no? Means the change in velocity. What is the change in velocity means? The change in velocity means the final velocity minus initial velocity. The final velocity minus initial velocity. Final velocity means what? Which is denoted by v, and initial velocity which is denoted by u. Where acceleration means v minus u by t. v minus u by t. It means final velocity minus initial velocity by time taken. That is it's a formula. We can also calculate the formula for the accelerations, v minus u by t, where acceleration is denoted by small a. What is the formula? The formula of acceleration is v minus u by t. Okay, now let's talk what is this retardation. Okay, what is this retardation? As the same as retardation. What is that retardation? Retardation means the negative acceleration, that is called what? Retardation. For example, the negative acceleration, it means the decrease in velocity. The decrease in velocity is called what? Retardation. You have seen due to the constant velocity, when it decreases, that is, it means the velocity is decreasing. For example, if the acceleration of a body is minus 5 meter per second square. Yes, minus 5 meter per second. What does mean? The body of retardation is, it means the body of the retardation is what? 5 meter per second square. It means that the velocity of the body is decreasing at the rate of 5 meter per second in 1 second. Here is the one thing. What do you mean by the retardation is, or what do you mean by if the acceleration of the body is minus 5 meter per second square? Then what does it mean? It means that the velocity of the body is what? Decreasing at the rate of 5 meter per second in every second. In 1 second. It means 5 meter per second in 1 second. The velocity is decreasing at the rate of 5 meter per second in 1 second. So the retardation means what? The negative or the decrease in velocity, that is called what? Retardations. Now SI unit. What is the SI unit? Okay. Now unit of acceleration. What is the unit of acceleration? It means unit of velocity by the what? Unit of time. That is unit of velocity means what? Unit of velocity meter per second square. Meter per second. Sorry. Velocity is the unit of velocity is what? Meter per second, and the unit of time is what? Second. It means what? The unit of acceleration means meter per second square. You can generally write also in this way also. You can write meter per second square also in this way also, or we can write meter per second square also in this way also. You can write anyways as you like. Okay. So therefore the SI unit of acceleration is what? Meter per second square. As the same as the SI unit of acceleration is also the meter per second square. So there is no any difference in the SI unit of the retardations. So it's meter per second square both. Okay. Now let's talk about some of the questions and some of the basic concept about this one. Okay. Okay. Now let's talk about the uniform accelerations. You have studied what is acceleration, what is retardations. Now let's talk about the uniform acceleration. What is that uniform accelerations? When a moving body changes its velocity or uniformity with the time, then the acceleration is said to be the what? Uniform accelerations. Now look at the graph. The body is moving in a straight line with the time taken. Yes, that in these conditions we can say that what? About the uniform, that is the what? Uniform accelerations. So a body is moving with the same as the time taken. Okay, it means when a body is changing its velocity unfamiliar with the time, unfamiliar with the time, with the same with the time, that is called what? That is uniform accelerations. The best example of uniform acceleration is when a body is freely falling from the above. Yes, that is the best example for the uniform accelerations. So a body falling from a height towards the earth is the best example of accelerations. Suppose this is the what? Markers. Yes, when you drop this marker from a height, that is the what? That marker should fall down in the uniform accelerations. It means it has a somewhat the constant. Yes, so for the uniform velocity, it is the initial velocity and the final velocities become equal. In the what? In a uniform accelerations, the initial and the final becomes what? Equal at the time. So the acceleration is equal to, as you know, acceleration is equal to b minus u by t. Yes, where b is equal to what? U. So when the b is equal to u, then you know a is equal to b minus u by t, and when b is equal to 0 by t, it means 0 meter per second square. It means what? Uniform acceleration is what? 0 meter per second square. So when a body is moving with the uniform accelerations, then what? Its velocity is what? 0. Yes or no? It means its velocity is what? Always 0. Okay? Okay. Now let's talk about the equation of motion in a straight line. So this equation of the motion in a straight line is a very important for your exam point of the view also, and for the numerical problem. While you are solving your numerical problem, most of the questions are related from the equation of motions. So please try to understand and read carefully. Okay, and listen carefully. Now here let us consider here in the figure. In this figure, the point of initial point which is denoted by u, okay, and in final point which is denoted by B, and the distance time taken T, and the distance covered by the S, where the distance covered is denoted by S, initial velocity is denoted by U, final velocity is denoted by B, and acceleration is denoted by T, and time taken is denoted by T. Okay, so this is the short form. SUBAT also we can consider. S stand for distance covered, U stand for initial velocity, B stand for final velocity, A stand for accelerations, and T stands for time taken. Now let's do the first equation. What is the first equation? Consider the motion of the body is moving from A to B. A to B is in the moving. Yes, A reaches to the B. A reaches to B in a straight line as shown in the figure. So, as you know, acceleration means A is equal to B minus U by T. We have studied acceleration is equal to what? B minus U by T, or we can simply B minus U is equal to AT. Yes or no? A is equal to B minus U by T, where we can also write their cross multiplication. B minus U is equal to A into T. So now B is equal to U plus AT. What is U plus AT? This is our first equation. B is equal to U plus AT is our first equation. So how it is once again said, acceleration is equal to B minus U by T, where then cross multiplication, B minus U is equal to A into T. Yes. Now this minus goes to next side. Then what? Minus change into plus. So B is equal to U plus AT, where B is equal to what? Final velocity. U is equal to initial velocity. A is equal to what? Acceleration. And where T is said to what? Time taken. So B is equal to U plus AT is our what? First equation. Now second equations. Now second equations. What is second equation? According to the definition of the velocity, we have already studied about the velocity. According to the definitions, average velocity we have studied about what? U plus B by 2 in the previous class. We have studied average velocity is what? U plus B by 2, where initial velocity plus final velocity by 2. And also know that velocity is equal to what? Distance traveled by the time taken. Yes, in this case, when this is velocity and this is the same equation, and both of them by combining this 1 and 2, we have to say that now we can write what? U plus B by 2 is equal to S by T. Okay, when this both are equal, yes, according to definitions of the velocity, it means U plus B by 2 is equal to S by T. What is S by T? So we U plus B by 2 into S by T. Now 2S is equal to U plus B into T, or S is equal to U plus B by 2 into T. So this is our second equation. What is U plus AT? And from the second equation we have studied S is equal to U plus B by 2 into T. When the value of B, we have to keep the value of B in this equation. Second, we have to keep the equation 1 into the second, that is the value of U. When you keep the value of U, instead of that U plus B, that is B stands for what? U plus AT by the 2 into T. Whereas S is equal to U, 2U plus AT by 2 into T. Whereas S is equal to UT plus 2UT plus AT square by 2. Here we have to separate the terms 2UT by 2 plus AT by 2, where 2 is these both will be what? Cancel, and remaining is what? Ut plus, to further it is cancelling, 1 by 2 at square. So our third equation is what? Ut plus half at square. This is our third equation. Okay? Okay, now the fourth equations. What is our fourth equations? Okay? Now you have already studied in the first equations. B is equal to u plus 80. In the first equation we have studied on that. B is equal to u plus 80. Now we have to square on the both side. We have to square on the both side. While we are squaring on the both side, then b square is equal to u plus 80 को whole square. It's a both squaring. So according to the formula, what is a plus b whole square, that is equal to a square plus 2ab plus b square, at the same as u square plus, it's equal to u square plus 2a means u into b means 80 plus a square d square. Now u square is equal to b square is equal to u square plus 2. We have to take the common in this case. What we have to take? Common. 2a is common and remaining ut plus 1 by 2. Because here 1 by 2, these 2 and 2 will be cancelled. Yes, these 2 to cancel and the same thing will be remaining here. So the t is taken the common here, 2a, whereas 1 by 2, 80 square. Yes, it means our fourth equation is what? U plus u2 plus half 80 square means it is a stand for what? Yes. So b square is equal to what? U square plus 2a. Yes. So this is our the equations related to the we have studied in the list of fourth equations. Yes. So b square is equal to u square plus 2a. Yes. Here I will write some things. Here important questions. In the first equations we have to study about what? B is equal to u plus 80. Where in second equation we have to study about the what we have to study? In second case we have to study in the second equations we have to study s is equal to u plus b by 2 into t. In third equations we have to study about the s is equal to ut plus half 80 square. Yes, s is equal to ut plus half 80 square. And in fourth we have to study about the what? b square is equal to u square plus 2as. So there are the four equations are very important for your exam input and for your examinations also. You have to derive it in your copy, and the same I have done in your in your boards. Okay, so you have to do this in your copy. Okay, thank you. Yeah!